Good morning, children. Let us continue with the class now. So, structure and function of living organisms. Part 1 it is. Already you have learnt about how the plants have different structures, shapes and all those things, isn't it? And what about the root system, shoot system, everything. And how roots and shoots are going to help the plants for its growth. All this you have learnt, isn't it? Now let us go about the leaf. Leaves are a very important part of a plant. A leaf is a thin, flat structure, mostly green in color due to the presence of a pigment, chlorophyll. It is borne on a node of the stem or branches. So you can see here, children. See? Now this is you can see these are leaves, isn't it? And this will be the stem part. Can you see the stem part here? See, this is the stem part. So you can see this leaves are arising from the stem and this is called as node region. And this is one more node. This is one more node. Understood? And in between this node to this node, can you see between this node to this node, you see there is a space. That space is called internode. Understood? That is called internode. And you see here, in between this, see here, this is, you can see the new structure is going to rise, which is going to increase the height of this plant. You can see apical bud it is. Apical means which is on the top. Okay? Apical bud. So sometimes what happens in between this petiole, so this structure which is attaching the leaves to the stem, this structure is called petiole. So what happens in between this petiole, that is the nodal region. In between petiole and the stem, again small buds will arise. And that bud is called as the axillary buds. That is called as axillary buds. So this is about the leaves. You see different structured leaves here. This is one. This you see. This structure is different from this structure and the size, shape. Isn't it? It is different. Then you can see this leaf. This is again different. See, it is thick. It is thick leaf. Okay. And see it is long also. Long. And look at the midrib here. It is different. So in this you can see difference. So like that, you see different plants have got different leaf structures. See here. Look at this leaf. This is different. See the petiole, that is different. Look at this plant. Okay. And see the flower here. And look at the petiole of this. So every plant has got its own structure and it differs from one plant to the other plant. It differs. Shape, structure, size, everything. But almost every leaf, if you see here, they are green in color. All these are green in color. You can see here. Look at this leaf. Look at this leaf. Isn't it? This leaf, everyone are green in color. Why is it green in color? Because there is presence of a green pigment called chlorophyll. And because of this chlorophyll, what happens? They look green in color. Understood? So that is what is said here. Leaves are a very important part of a plant. Why they are called as very important plant? Because they are able to prepare the food by a process called photosynthesis. That is why the leaves are very important in a plant. So a leaf is a thin, flat structure, mostly green in color due to the presence of a pigment called chlorophyll. That's what I have shown you now. It is borne on a node of the stem or branches. Node also I have shown you. Nodal regions I have shown. Now structure of a leaf. A leaf generally has a stalk called the petiole. Can you see here? This is the stalk and this is called as petiole. Leaves of monocot plants like rice, wheat and maize and some dicot plants do not have a petiole. Some leaves do not have petioles at all. Okay? They are very small. Some things, see, here you can see, in this petiole is very small. Can you see? It is very small in this. In this there is no this one at all, petiole at all, in this leaf, no petiole. Directly it will be attached to the stem. This part will be attached to the stem. Okay. Now, so a leaf generally has a stalk called petiole. Leaves of monocot plants like rice, wheat, maize and all, monocot means which cannot be divided into two halves. And some dicot plants do not have a petiole. They are called sessile, which do not have petioles are called as sessile. At the base of the petiole is a pair of very small leaves called the stipules. Can you see here? called as the stipules. The stipules protect the young leaf. The broad expanded portion of the leaf is called the leaf blade or lamina. This part. This part is called as the leaf blade or lamina. The tip of the leaf is called the leaf apex. This one. Tip of the leaf is called as the leaf apex. And its edge is called the leaf margin. This one. This part is called as the leaf margin. Now, see here. So you can see this broad part is called as the lamina. There will be a midrib. This middle one, you can see this is midrib, and it has got small branches. Can you see? See this. This is a small branch that is called as veins. That is called veins. Tip of the leaf is called apex. The middle one is called midrib, and the whole part is called as lamina or leaf blade. And this is the attachment of leaf to stem is called as a petiole. And in between this petiole and the stem, small buds arise. That buds is called as axillary buds. And at the nodal region only you see the petioles of the branches at the nodal region. Understood? Now the lamina has a thick midrib in the center. This one. It has got a thick midrib in the center. You can see this. This is lamina. This full is lamina. Can you see a midrib here? This one. This is called as a midrib. Then the midrib forms many branches on either sides of the lamina. These are called veins. Can you see here? See? Can you see? This is called as veins. Got it? Small branches. The midrib is going to give branches on either sides. Then these veins in turn divide and subdivide to form a fine network of veinlets. So if you see like this, you can see again there will be branches. Small branches you can see here. This is big branch. In between you can see small branches. Okay? And these branches what we call as veins. Veins it is. So these are called veins. These veins in turn divide and subdivide to form a fine network of veinlets. Those veins will again divide to form veinlets. The veins provide support to the lamina and transport water and food in the lamina. So these small branches, tiny branches like this will be forming a network that is called as veinlets. So the veinlets will start absorbing the food and water and transport it to other parts of the plant. So what happens? The veins provide support to the lamina and transport water and food into the lamina. Now types of leaves. Leaves may have a variety of margins, different types of tips and different shapes of the lamina. Already I have shown you some leaves. You have seen how they differ in their shape, size, isn't it? And their pointed ends. See, all this are different types. Look here. Look at all this. So all these are different types, isn't it? Okay, now look at this also. So these are all of different types and shapes. Can you see? Yes. Now we will see here. So the leaves are looking different. See here. Leaves may have a variety of margins, different types of tips and different shapes of the lamina. So did you know the giant water lily, Victoria regia, has the largest leaf about 1 meter in diameter. The leaves itself is broad. The lamina is broad. How much? It is 1 meter. Diameter it is 1 meter. So difference in lamina. Leaves are classified as simple leaves or compound leaves based upon the difference in their lamina. So like this if you see small ones and big ones if you see, that itself shows that whether it is simple leaf or compound leaf. You can see here leaves are classified as leaves, simple leaves or compound leaves based upon the difference in their lamina. A simple leaf has a single or undivided lamina, while a compound leaf has the lamina divided into a number of smaller units called leaflets. For example, leaves of a mango, guava and money plant are simple leaves, while those of rose, neem and tamarind are compound. So what happens? The lamina will be like this. See, in the rose, can you see here? See, it is not even. there is branches. Can you see here at the sides? So this is compound leaf. Understood? A simple leaf means there is no cut at all. Simple it will be. Full it will be covered. Edge will be totally simple. So that is simple leaf. Compound leaf means edges will be like this. Can you see? That is compound leaf. Okay. So now did you know here water plants can have two types of leaves. The submerged leaves may be finely divided while the floating or aerial leaves are of simple variety. So water plants are of two types in water plants also. The submerged leaves means what? Which is inside the water may be finely divided while the floating or aerial leaves are of the simple variety. So you can see now for example lotus if you take, where are the leaves? Leaves are floating. Submerged plants are there, hydrilla and all those things, no? Those plants are there and their leaves are different. So it depends upon the type of habitat, whether it is on the surface or whether it is submerged. Based on that you can see two types of leaves. Let me show you the image now. So you can see here children, this is the stem part of the plant. This is the leaf. Okay. In the leaf, can you see these cuts here? See, this is what we call it as a compound leaf. If there are no cuts like this, then you call that a simple leaf. So you can see in the leaf itself, this part. What is this? This is called as a midrib. This midrib will give rise to so many branches on either sides. These branches are called as veins. Now these veins further divide and show so many small structures which will be overlapping. From this it will come here, from this it will go there. So they will be forming a network of veins. And those network of veins we call it as veinlets. Okay. Now this veinlets will help in carrying out the food and water to various parts of the plants. So lamina you understood, midrib you understood, veins you understood, veinlets also understood. Now you can see this leaf is connected to the stem with the help of a stalk. We call that as petiole. Okay. And where is it attached? It is attached to the nodal region of the stem. This is called as the nodes. From one node to the other node we call it as internode. There is one more leaf arising means that becomes one more node. So this is one node, this is one node. Then it becomes an internode. This place is called as an internode. So you can see here small green leaf-like structures arising from the nodal region. This is called as stipule. It's called as stipule. And then this is the leaf base. See, this is not a base. This is the base where it is held back to the stem. That is called as the base. And in between this petiole and the stem, small buds arise. So these buds are called as the axillary buds. So this is the structure of a leaf. So you can see here. Yeah, you can see here. Yes. You see here children. So this is a banyan leaf, no? So here people tree and banyan, you see that there is a difference in the leaves. So you can see a midrib is very clearly given. And you see the veins. Okay. And here you see the network of structures. See here. This network of structures only called as veinlets. It's called as veinlets. And then this is the petiole where it is getting attached to the stem. So you can see this is one more leaf where the petiole is not there. You can see. I have already shown you. Then, so this is ficus, this is cucurbita and cinnamon. Cinnamon you know now? Here it is given cinnamon, it is cinnamon. So you know about the chekke, dalchini, that one. Then here you see canna. Look at this leaf, that is different. Bamboo. Bamboo leaves also you are seeing. And borassus. So you look at the shape of this. It is different. Okay. So now this is a compound leaf. Whereas this is a simple leaf. Why? You can see this. Okay. This is what compound leaf. This is a simple leaf. So types of parallel venation. Parallel venation. Parallel venation means what? See, it is moving like this parallel. Can you see? This is called parallel venation. See? It is not going and crossing. If it intersects, then it is not parallel. Because here it is not intersecting. This is a parallel venation. Did you understand? So let me stop it here children. We will continue in the next class. Thank you.